So now we'll see what normalization is: 1NF, 2NF, and 3NF. So here database normalization reduces redundancy and it also improves data integrity. Understanding normal forms is crucial and it leads to efficient database designs. And what happens in 1NF, 2NF, and 3NF? We will use clear examples and we'll see 1NF, 2NF, and 3NF. For example, 1NF is for two. Basically, 1NF is one normal form, 2NF is two normal form, and 3NF is three normal form. First, we'll see what is first normal form, which is 1NF. There are some rules which is eliminates repeating groups. So now rules eliminating repeating groups. So now each column must contain atomic values. Atomic means indivisible, not no list within a cell, which is a single column. A column should contain single values, not repeated one. A table with a skills column, it lists multiple skills. This is not 1NF. So solution is we have to separate rows, which create separate rows for each skills. Each cell hold only one value. So here what we have to do is we have to create separate rows for like values, separate column for every values to get the data into 1NF form. And we have to solve the we have to sort out the skills or sort out the things into different columns. So we'll see an 1NF example, which is before normalization. So here table data, employee ID, employee ID, name, skills, in which employee ID is 1, name is John Doe, and skills is programming, database, and networking. So we can see that programming, database, and networking are 3 skills combined in a single row. So this is not into 1NF form, so it can violate our one normalization. So we have to do what we have to do is we can separate these rows in separate columns and write these skills separately, because this makes the data non-atomic and it introduces repeating groups. This table needs normalization. The skills column contain. So now after normalization, like we have to normalize this data. So we have separated the data into separate columns, which is programming, database, and networking. So now we'll see what second normal form is. To convert any data table into second normal form, the data table must be in 1NF. So which is the first prerequisite for 2NF, and all previous rules are applied as the same. So eliminate redundant data, removes partial dependency, non-key attributes must be dependent on the entire primary key, composite primary key needed. This form applies only if the table has a composite primary key, that means multiple columns make up the key. Violation examples: if skills depends only on skill D, part of the key, it violates 2NF. So in this the key should not be dependent on this part of the key. For example, we can see identifying identifying what partial dependency is. Partial key is employee ID, skill ID, and now notice how the skill attribute depends only on skill D. It does not depend on the employee ID, the part of the key. This creates a partial dependency which violates 2NF. So we can see here employee skills is employee ID, skills D, and skills year of experience. Now key is key, employee ID, and skill D. In problem, skill depends only on skill D, not on employee ID. Okay, so now we'll see what 3NF is. 3NF, to convert any table into 3NF, the table must be into 1NF and 2NF. So this is a starting point for 3NF. All 1NF, 2NF, and 3NF or 2NF rules are applied. In eliminating transitive dependency, non-key attributes must not be dependent on any other non-key attributes. This means the indirect dependency. Violation examples: if department name depends on department ID and department ID depends on employee ID, this is a transitive dependency. This violates the 3NF. And in summary, we can see the importance of normalization, which is 3NF, 1NF, and 2NF. Normalization is vital for database health. It minimizes the data redundancy. It also ensures data integrity. Each from builds upon the last. This creates a robust and efficient database structure. Thank you so much.